So first we will draw the couple polygon. So I have taken the couple polygon values here. Okay, so you place your angular position mass, because keeping these as a reference only we are going to draw here. I will draw in this space. Okay, so first one, you fix the origin point here. Okay, I'm going to fix the origin point here as O. This point, origin point, I fixed here. So the first value is negative 1.6. I'm going to take this scale as 1:1. 1:1 means whatever the value here, I'm going to same reproduce here. Okay, so minus 1.6 means I'm going to take it as 1.6. So here we have drawn towards right, but since this value is negative, so I'm going to draw towards the left side direction. So this is my O point. From here 1.6, I'm going to draw towards left side. Okay, this is 1.6, so I'm drawing towards left side. Okay, next one, next value is 0. Okay, then you leave this one. Next you go for 4.2. Okay, this mass is mass B. So we have drawn for mass 1. Next you have to go for mass B. So what you have to do, just place your ruler here. Okay, place your ruler like this and move towards the point, this point. Okay, and this point you have to draw this one. So I give this name as A dash, and place your ruler here and move towards the point and draw 4.2. Since the value here is 4.2, 1, 2, 3, 4, 4.2. So this is B dash. Okay, next 7.2, that is mass C. This is A, B, and this is mass C. In this direction it is 7.2. So what I am going to do, place the ruler here in this direction, and without changing the position, just move here. Okay, now measure the distance 7. 1, 2, 3, 4, 5, 6, 7, 7.2. Okay, now this is C dash. Okay, next value is this one. This is unknown, so you keep as such. So last one is 9.6. 9.6 in this direction. Okay, so I will keep here. So this is 9.6. Place your ruler here and without changing the position, move to C dash. So from here you have to draw 9.6. The value here is, so here I can show 9.6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.6. Okay, so I'll be getting here as 9.6. Okay, this is D dash. Finally what you have to do is, you are supposed to close the polygon. Okay, so I am going to close the polygon like this. Okay, now you can see the dash line. So this will give the value for the y plane. Okay, this will give the angle. Okay, angle in which the mass which is placed in y plane will be taken from this D dash O point. Okay, so we have to consider this one. So now what I am going to do, just place your scale here and try to reproduce in the position of plane. So this is a balanced couple. This is balanced couple. So what I am going to do, I will just place it here, measure the distance. So this distance will give the R value. So it is nearly 1, 2, 3, 4, 5, 6. So don't change the position, place your ruler and move towards the point over here. So this is one balancing mass with respect to plane Y. So I can write like this. This is theta y and this is ry and here it is my. Okay. So now from the coupled polygon we have constructed this one. Okay. Next what you have to do, you have to draw the force polygon. Before that we have to find the value of mass with respect to y plane. So now we will see the mass, how to find the mass. Okay, here you can see from coupled polygon by measurement the value is 0.04 MO equal to vector d o dash. D o dash is nothing but what? This is d, this is o dash. Okay, if you measure the distance, so you will get vector d o dash equal to 7.3 kilogram meter square. Already the unknown mass is 0.05 my. Okay, you can see here this is 0.0 my from the coupled table. This is equal to the vector from the measurement you have seen. So from this my equal to 7.3 divided by 0.04, you will get 182.5 kg. Okay, so the mass of the coupled plane, this mass we have calculated, and this comes around 182.5 kg. Okay, so next we are supposed to draw the force polygon. Okay, so now we have found what is the mass here, so only unknown is this one. So next we have to draw this force polygon. So next we are going to draw the force polygon. For that I am going to take the fourth column and I am going to draw the values. Okay, so here I am going to take scale 1:4. 1:4 means I am going to divide this by 4. Okay, so I will get 4 here, approximately 5, 6, again 4. Okay, now we will, based on this position of masses, I am going to draw the force polygon. Okay, again I am going to fix one common point, so I will fix here. This is O point, O dash. Okay, here the value is positive, so initially from O towards mass m1 will be in right side direction. So I will take this one, 16 by 4. Since we have taken 1:4, so 16 by 4 I will get 4. So first I will place the scale here in this horizontal direction and I am going to draw here force. Okay, in terms of centimeter. So first one 4 centimeter. 1, 2, 3, 4. Okay, so this is A. Okay, so next one, this value you leave it, this is unknown. So next one you take, this is A, this is B, C and D. Okay, next B mass is 21. I told you divided by 4 approximately you will get a 5. Okay, now B mass is here. Place your ruler here, don't change the position, move towards this point. 1, 2, 3, 4, 5. Okay, this is B. Okay, so next one, third mass, this is C mass 24. So you will get 24 by 4, you will get 6. So from this, don't change the position, move towards the point B. From here I am going to measure 1, 2, 3, 4, 5, 6. So this is C mass. Okay, so next one is D mass, it is 16. So 16 by 4 you will get 4. So this is my fourth mass position. Place your ruler here and move towards this point. Again 4. 1, 2, 3, 4. Okay, this is D. So apart from mass 1, mass 2, mass 3 and mass 4, we know one mass angle. Okay, that is y plane. Okay, this one we have found out. It is with some angle 12 degree. Okay, now place your ruler here and move towards the point D. And just draw this one. Okay, the same r distance, measure it and you have to draw here. Okay, so this distance is equal to the r value of mass y plane. Okay, so next your final, you have to conclude with the closed polygon. Okay, so this one is the initial point, this is your final point, so connect these two by a straight line, so that will give the unknown mass with respect to mx. So this one is this one, balanced force. (0.1 mx), this is 0.1 my. Okay, now measure the distance between O and this point. Okay, I will take this as theta. So between O and theta, measure the distance. Okay, so from that you can find what is the value of mx, mass in x plane. Okay, so I already calculated, I will show. So here you can see, to find the angular quotient, okay, you have to do this one. So from vector EO, force polygon shows the balanced force by measurement 0.1 mx equal to vector EO. This one is EO. If you measure the distance between these two, you will get 35.5 kilogram meter. So from this you keep this one, mx equal to 35.5 divided by 0.1, you will get 355 kg. This is the mass for x plane. Okay, and already we have found for y plane. I will show here, this is the mass for y plane. Okay, so after completing this one, after finding this one, so what you have to do is, from here you place your ruler and just move towards this one and draw here. Just to measure the distance, and this is mx and this is rx. Okay, so now this theta will give the angle between the d and mass in the x plane, and this theta will give the angle between mass a and y plane. Okay, so now you can see the x plane mass and y plane mass is completely balanced. Okay, I hope you have understood how to balance several masses of different plane. Thank you very much. We will see in one more topic. Thank you.